Hello, and this is the video for section 6.2 and 6.3 on parallelograms. And so let's go ahead and get started. This first slide is just some basics about parallelograms, and it just goes over its definition, like you all have seen in the past. A parallelogram is a quadrilateral with both pairs of opposite sides that are parallel to each other. And so just a couple of reminders. The matching arrowheads, the parallel line symbols, are these items right here. All right, so the double parallel line symbols means the top and bottom sides are parallel, and then the single parallel line symbols, those matching arrowheads, are telling you the left and right sides are parallel. And so just a couple reminders there about your symbolisms there on your pictures. Here on that unboxing right here, this is just the symbols in terms of like how it might be typed. That says segment PQ is parallel to segment RS, and segment QR is parallel to segment SP. And one last little symbol right down here, this little thing I'm circling is the parallelogram symbol. That means the same thing as the whole word parallelogram written out. And so that might save you some writing. And parallelogram is the only quadrilateral that has its own symbol. So just kind of keep that in mind going forward. All right, so you know some things about parallelograms already, so we'll review some of those, and there might be some properties that you don't know, and so we'll go ahead and complete our notes. We're going to need to know the 6 properties of a parallelogram, and so if we get started with the first one, the definition of a parallelogram is that if you have a parallelogram, the opposite sides are parallel to each other. That was just the definition we did on the first slide. That means you could add the parallel line symbols to the top, bottom, left, and right sides, kind of like what I'm doing here. All right, so that's what you know about parallelograms so far. Opposite sides, both pairs of opposite sides are parallel. But property 2 says its opposite sides also have another relationship, and the opposite sides are congruent to each other. And so, like, if you know the left side is 5 units, the right side would also be 5 units. And so you can legally tick the top and bottom and left and right sides, and you know that those opposite sides have to be congruent to each other. All right, so if we keep going, we're talking about the angles now for property 3. If you have a quadrilateral and it's a parallelogram, then its opposite angles are congruent to each other. And so that just means this angle here that's acute in the bottom left will be congruent to the angle across from it, that top right angle. So those are both going to be the same. Likewise, you could say the 2 obtuse angles are congruent to each other. And so that's a property of parallelograms that you all need to know. Opposite angles are congruent to each other. Now the consecutive angles, this one's a little different. This one is the supplementary relationship. And so let me just kind of put some numbers in here. If this is a 60-degree angle on the bottom left, this top angle here has to be 120 degrees because those angles are same side interior angles. And because the tops and bottom sides are parallel, same side interior angles are supplementary. So this is a property. It's essentially coming from same side interior angles, but any pair of consecutive angles have to be supplementary. And that just essentially means any 2 angles that are located on the same side. And so, like, for instance, these 2 angles that I'm circling in orange, both of those lie on the bottom side. And so those 2 have to be supplementary to each other. And so any 2 angles on the same side have to be supplementary, or you could just think of them as consecutive angles. But that's property 4. Property 5 is the diagonals are bisecting each other. So let me go ahead and put this into our notes. They bisect each other. And so if we draw our diagonals, and so there's my 2 diagonals there, the point where the diagonals cross, this big dot right here, that big dot acts as a midpoint. Because diagonals bisect each other, that dot counts as the midpoint. So this is the midpoint of the long diagonal, and it's also the midpoint of the smaller one. So you are allowed to legally tick the diagonal pieces like so. Now the diagonals are not congruent to each other in a parallelogram, so they will have different ticks on them, but there's your relationship there. And last but not least, the opposite sides, one pair of opposite sides is both parallel and congruent. Boy, I wrote that terrible. So parallel and congruent. And so what that means is that you can add if you have the parallel line symbol on one side, but also on that same side, you have a congruent side tick. This unique combination guarantees a parallelogram. And I want to show you this real quick. The reason why this will guarantee a parallelogram is because property 6 is essentially property 2 in disguise. It's a shortcut. Now, here's the reason why it's property 2. If you focus on this little diagonal right here, this diagonal creates 2 triangles. Well, the 2 triangles just happen to be congruent to each other. And let's just prove that real fast. Because both triangles share that diagonal, we can put a double tick that counts for both sides. That's the reflexive property. Well, both of the triangles have 2 sets of congruent sides, but I'm going to add this little purple tick right here in these angle spots, this angle here, because those are alternate interior angles. Alternate interior angles are congruent if you have parallel lines, which we do. Here's my parallel lines there. And so those are alternate interior angles. And so the triangles that we have, these triangles are congruent because of side angle side. We learned that back in Unit 4. And because the triangles are congruent because of SAS, then you could say any unticked things have to be congruent as well. Well, the top and bottom sides are unticked. Those pieces have to be congruent to each other because of CP, CTC. And so by having the combination of one pair of opposite sides being parallel and congruent allows you to say that you have congruent triangles, the tops and bottom sides are congruent. And so now property 6 is essentially property 2. We know the tops and bottom sides have to be congruent to each other, as well as the left and right sides are congruent to each other. All right, so there are all of your properties there. And so what we're going to do is we're going to use these properties on each of the questions that we're going to do on our examples here. All right, so if we do question 1A, here's your process. What you're going to do is, first of all, write down what's given to you. So JFH is 67. So JFH is here. So put a 67 in angle JFH. GK is 3. So that's going to go there. 80 degrees is GJH. So GJH is this angle down here. That's an 80. FJG is 5. Okay, and so now that we put everything into the diagram, now we have to apply our properties of parallelograms. And so the first question is, okay, we want JK. Well, JK is this little purple length right here. And so what we have to do is we have to ask ourselves, and I'll go back, back on the notes here. If you look at your properties and you ask yourself, okay, what is JK? JK is this purple segment there. Is JK one of the pairs of opposite sides? And the answer is no. And so we can't use properties 1 and 2. And so if we look at JK again, is JK a pair of angles, either opposite angles or consecutive angles? And again, the answer is no. And so that means we can't use properties 1, 2, 3, or 4, but JK is a diagonal or part of a diagonal. So that tells me for question number 1A, we're going to need to use property 5 from our notes. All right, so that means property 5 is valid since this is a parallelogram. That means we can legally tick the diagonal pieces. And so if GK has a 3, that means we can copy the 3 onto JK because the diagonals bisect each other. And so your first answer is 3. All right, so for question 1B, now this one is asking you for the angle JFG. JFG is this full angle way up here at F. And so if you're having troubles visualizing a parallelogram question or a rhombus question or any kind of quadrilateral, I would suggest that you draw the quadrilateral without your diagonals. All right, so here is your quadrilateral, no diagonals. And what we can now do is figure out, okay, from our original diagram, what our whole angles are. Now the angle at J is 80 and 5 combined. And so if I add up 80 and 5, that's 85. And so angle J is 85 degrees. Now with this picture here, we can apply our properties. Now these are angles. And so that tells me if we go back to our property notes here, we're going to look at properties 3 and 4, which says we could do stuff with the opposite angles and consecutive angles. All right, so let's apply properties 3 and 4. A property 3 says opposite angles are congruent. And so I can legally put an 85 at G. because it's an opposite angle of J. Now let's use property 4 that says consecutive angles are supplementary. And so that means the angles next to the 85s, if we subtract those from 180, makes the missing angles at F and H both 95. All right, so now we've got our diagram filled in. Now we can see if we can answer the question. JFG is the full angle at F. So this answer is 95. But let's just say, let's do a what if. What if I didn't ask you for the measure of angle JFG? What if I asked you for the measure of angle GFH? That's this little double ticked angle right here. And so if I asked you for that angle, what you would do is you take the 95 that you know that F is, the full angle at F is, and you would subtract the 67 from that, and that would give you 28. So this angle here would be 28. And so there's an extension of question 1B. If I asked you for one of the smaller pieces, you could use the 67 to help you find that 28. All right, so let's finish this out here. The measure of angle FGJ. So FGJ is this angle right here. FGJ is this angle way up here in orange. It is going to match with the 80 that I circled. This is a pair of alternate interior angles. And so what I want to remind you all on this lesson is that within parallelograms, we're going to be using AIs and SSIs a lot. So please be on the lookout for these two angle pairs. In this case, it was alternate interior angles that was needed to solve the question. All right, so that angle up at FGJ is 80. All right, so what we're going to do is we're going to just keep doing more examples on these problems here and using these properties. And so we'll get a little bit tougher as we get going here. And so for problem 2A, these are angles given to us. 60, 6y, and 5x plus 10 are angles. And so that means we're going to use properties 3 and 4 to help us answer the question. So if you want to, if you need to, you can go back to your notes. I'll flip back here. Property 3 says the opposite angles are congruent. So if we apply that, we can put a 60 where the 6y is because it's an opposite angle with the 60 down here. And so now that we know that, we can use property 4 of the tree of our notes that says the consecutive angles are supplementary. So that means we could put a 120 into the other angles. And now that you have your expressions set up, now you can set up your equations. Now you're ready to pull this off to execute the problem. 6y is equal to 60. And then for the x, you could go 5x plus 10 is equal to 120. All right, so that's going to take care of this type of question here. So if you solve this out, so y will be 10 whenever you get that done. And then if you finish out the last one here, so that'll be 5x plus 10 is equal to 120. And so if you subtract 10 from both sides, that'll be 5x equals 110. And so now all you have to do is just divide 110 by 5. And so that makes this answer 22. So y is 10. X is 22. And so that's going to do it for that question there. So question 2B, on the previous page here, question 1C, I mentioned we have to be looking for alternate interior angles or same side interior angles. Well, we're going to do the same thing on this one. All right. So we're going to use AIs. And so this angle that I'm circling, 124, is going to be an alternate interior angle pair with the 4x plus 24. So this will give you your first variable. And so now what we're going to do is subtract 24 from both sides. And so that'll be 100. And if you divide 100 by 4, that should give you 25. All right, so there's your first solution right there. X is 25. Once you have your X, you've got that done. Now what you'll do is the same process again. You have a different AI angle pair formed by different sets of parallel lines. And so this is a different set of AIs. And so now what you could do is you could set up this angle 3x minus y to equal 28. Now, you know x is 25, so you can actually substitute that into your equation. And now you can solve this out. Well, 3 times 25 is 75. So what you'll do is subtract 75 from 28. And so what that'll do is give you 47. It's a negative 47 when you subtract 28 and 75. Well, negative y equals negative 47 means if you divide both sides by -1, that's going to give you a positive 47 for that answer. All right, so that takes care of some of our basic examples on how to use your properties. You will do the same thing on questions 3, 4, and 5. So I'll go ahead and pause the video, take a few seconds to try these. I'll put the answers up here for you all to check. So we'll pause. We'll be back here in just a second. All right, welcome back. And so here are your answers to these 3 questions. Now, these are going to be using the basic properties of parallelograms, but you're going to be asked to do a little bit more algebraically. These are not going to be quite as simple as the questions that you've been doing. So for questions 3 and 4, both of these are going to be solved by solving a system of equations. All right, so let's get started on number 3. Let's go over that real quick. Because BE and DE, I'm going to circle these. These are parts of the diagonal BD. We're going to use property 5 of our notes that says the diagonals bisect each other. So we are going to we're legally able to bisect the diagonals. We're able to tick our diagonals like this. That means we can set some things equal to each other. All right, so this BE is 2x plus y. We can set that equal to 12. Now we're going to solve a system of equations. With a system of equations, you want your x and y to be on one side. You want your number to be on the other. So this looks good. This is the form that we want, but you need 2 equations. And so now what we'll do is we'll do CE and AE. Those segments equal each other. So 3x plus y is equal to x plus 2y. Now this is your second equation, but all of the letters are not on the same side. And so what we're going to need to do is to manipulate the second equation so we get all of our letters and numbers in the right spots. All right, so let's do some fast arithmetic here. Let's subtract x from both sides. If I subtract x from both sides, 3x minus x is 2x, and I'm going to subtract y from both sides. Excuse me, no, I said that wrong. Let me erase that. We're going to subtract 2y from both sides. If we subtract 2y from both sides, that's going to give us a negative y. And when I subtract everything from both sides, I end up with a 0 on the right. So again, just to rehash that step, we're going to subtract x, and we're going to subtract 2y from both sides. All right, now this is a formula that we like because all of our letters, our variables, line up on the same side. So 2x plus y equals 12. We'll put that first, and then we're going to line up the second equation right under it. So this is 2x minus y equals 0. And now this is the perfect candidate for elimination. And so elimination, if you forgot what that was, is you're allowed to add the equations together, hoping that we eliminate a variable, and we actually do. We don't have to do anything special here. 2x plus 2x is 4x. The y and the negative y add up to 0. And then the 12 plus 0 is 12. And so if you divide both sides by 4, you're going to get x is 3. Okay, so that's where the first half of the solution comes from. Once you have your first half of your solution, then you're just going to plug x, this answer, into any of the equations that you have. Let's just plug it in up here. So this is going to become a 2 times 3, which is 6. And so this equation now at the top turns into 6 plus y equals 12. Well, if you solve that new equation out for y, that's where the 6 came from for my answer. All right, so you're going to need elimination or substitution to solve these questions, whichever method works best for you. You're actually going to do the same thing on number 4. I'm going to go over substitution on this one. We'll get there in just a second. We're going to use the second property from our notes that said opposite sides of a parallelogram are congruent, so we can legally tick the sides like this. And so we can now say that y is equal to 3x, and we can say that x plus y is equal to 3x plus 16. And so this is a perfect candidate for substitution because we have a single variable right here that says y equals something else. If you see something like this, it might be a good idea to substitute. Well, anytime I see a y, which I've got down here, I'm going to replace that y with 3x. And so this will be x plus 3x equals 3x plus 16. And so what this does, this substitution, is it gets rid of the 2 variables. Now everything is in terms of 1 variable. And so I've got a 3x on both sides. And so what I'm going to do is subtract 3x from both sides. Subtracting 3x from both sides gives me x is 16, which is where I got the first half of my solution. Then you'll plug that back in and solve for y. Y equals 3 times 16, which is where I'm getting the 48. All right, for question number 5, this is giving you angles B and C. The only chance you have on this is to use the fourth property of your parallelograms, which just says consecutive angles are supplementary. So that means you're going to say the two angles, and you're going to add them up. So here are your two angles added up, and that has to equal 180. And so now it's a matter of solving a quadratic. And so we have an x squared plus a negative 3x. So that's x squared minus 3x. I'm going to subtract 180 from both sides, and that'll give us a negative 40. And so now this is just a matter of solving the quadratic. I would highly suggest you all know how to factor this. It'd be easiest to factor this. And so now it just comes down to the numbers that multiply to give you negative 40, that add to give you negative 3 are negative 8 and positive 5. And so now what you do is you set each parentheses equal to 0. So x minus 8 equals 0. So if you add both sides to this equation, x is 8. Go to the other parentheses, it's x plus 5 equals 0. You subtract 5 from both sides, x equals negative 5. So there are your two solutions. And now what I want to do now is review, make sure we don't forget this from the very beginning of the course. You have two potential solutions for a quadratic, but you do have to make sure, okay, do I keep both of them? Do I throw them both out? Or do I keep one and throw the other one out? You have to know which scenario is which. All right, so the rule is you got to plug it back in. Now, angle B is x squared. So if I plug in an 8 for angle B, 8 squared is 64. And you ask yourself, okay, does 64 make physical sense? Is it reasonable? What you're looking for are positive angles that make reasonable sense. If it's like a billion, okay, that's too big. That 64 is reasonable. All right, so that's a good answer. Right now, x equals 8 stays as a solution, but you have to plug it into all expressions. And so now if we plug it in for this term right here, negative 3x, negative 3 times 8 is negative 24, plus 140 makes this angle C 116. Well, that makes sense. It's an obtuse angle. It's good. I know the picture is a little wonky. It doesn't look like those match up, but that's fine. So we are good on this solution. So x equals 8 checks out. We have to include that as a solution. Now let's check the negative 5 solution. You are not throwing this one out just because the x is negative. It works. All right, let's prove it. If you plug negative 5 to x squared, a negative times a negative is a positive. And so this angle is 65 if I plug in 8, but also if I plug in negative 5, it's positive 25. That works. If you plug in the negative 5 into the angle C, negative 3 times negative 5 is positive 15. Positive 15 plus 140 is 155. I get another angle that works. And so both of these solutions are valid. X equals 8, x equals negative 5 are your solutions to this problem. All right, so what we're going to do now is move on to the next page. These are some more examples here. To make this simpler, let's just consider this stuff at the top a word bank or a property bank. And so we'll call each of these properties sentence A, B, C, D, E, or F. And so what I want you to do is look at the picture or the scenario and ask yourself, is there enough information to determine if this thing is a parallelogram? If so, justify your reasonable conditional form. Well, it's one of these 6 sentences, A through F. And if there's not enough information, then you'll just say it's not a parallelogram. All right, so go ahead and try these 4 questions for me, and we'll pause the video and we'll go over these whenever you're ready. Okay, so here are the answers to these questions. And so let's start to go over a few of these with you all. So for question A, this is either C or D. Either one of these will work. And so let me come back up here and let's focus on sentence C here. So sentence C says, both pairs of opposite angles are congruent to each other. So that would mean these 2 angles that I'm circling in orange, those are opposite angles. They're both 90, so they're congruent. And so if you look at the other pair of opposite angles, and I'll color them in a different color, they're both 90, so they're both congruent. And so that's why C would work on there. If we said opposite angles congruent, that's fine. You can certainly make a case for that reason there. Now, if you chose to go with sentence D, consecutive angles are supplementary. So let me kind of highlight that in a different color. Let's go purple. And so if we looked at consecutive angles, these two angles that I've circled in purple are both on the same side, the left side, so they're consecutive. And so they add up to 180. And so it doesn't matter which pair of angles you pick next to each other, they're all going to be supplementary. And so either one of the two answers, sentence C or sentence D, would get the job done here. Now, question B is not a parallelogram because it doesn't have enough information on the other set of diagonal ticks, or it doesn't have enough information on the other diagonal. And so this is what was on your notes. You have a single set of ticks on one diagonal, and then you had double ticks on the other diagonal pieces. When we don't have that in this diagram, and we can't assume anything. And so that's why this is not enough information to say it's a parallelogram. Now, this is actually a kite. When you get to section 6.6 and you learn about trapezoids and kites, you'll learn that that's one of the properties of a kite, that only one diagonal is bisected. And so that's not a parallelogram, it's actually a kite. For problem C and E, or C and D, your answers are up here. So for question C, there's no diagram. And so this one, you're actually going to have to draw the diagram yourself. And so if we just draw a quadrilateral like this, so MOAT means that's got to be MOAT. So something like this. And it says MA and OT cross. And so here is the diagonals that cross, they intersect at R. And so if MR and RA are equal, so we can put ticks there, and OR and TR are congruent, we can put ticks there. This was the fifth property of a parallelogram. So that's why sentence E is correct. And if you go down to the last one here, so let's just say we had a figure like this. So CRAB, and they tell you RCB, this angle up here is 60. CBA is 120. CRA is 120. So you have three angles of this figure given to you. Now, this is a quadrilateral, so you can subtract the three angles from 360, and that'll give you this blank angle at A, and that has to be 60. And because the opposite pairs of angles are congruent, you can go with sentence C, or you can go with the consecutive angles and go sentence D. So just like question A, D would have multiple answers there. All right, so that takes care of question 6. Let's move on to question 7. In order to answer question 7, you're going to need to plot your 4 points, E, F, G, and H. And so here's what I need you to do. Go ahead and do me a favor. This question says, determine if it's a parallelogram using slopes. You're going to need to find your slopes first. So take just a few seconds to find your slopes. Go ahead and pause the video, and we'll be back here in just a second. Okay, welcome back. And so let's go ahead and start doing this question. And let me give you a little bit better context on this. I know there's 4 points, and I say it says determine if it's a parallelogram. What we're going to actually do is I'm going to reword this question. Let me give you what the test is going to actually have you do. The test is not going to be, the test question is not going to be worded like this. I know this is not very formal, but this is essentially what your test question is going to ask of you. It's going to ask you, what is EFGH? So what is EFGH? And so the question is going to be at the end of the unit, here's 4 points. What kind of shape is it? What kind of quadrilateral is it? Now, it could be a parallelogram, rectangle, rhombus, square, trapezoid, isosceles, trapezoid, or kite. We haven't covered all those shapes yet, but this is what your test is going to be like. 4 points. What do they make? And so let's reword this question. So what we're going to do is ask ourselves, okay, what is this thing? And so when we look at the picture and we look at our diagram here, EFGH, and we kind of connect all of our dots. So here is EFG. Okay, so this is what our figure will look like. Now we could use a certain mode of common sense on this because this figure is on a coordinate grid. All the coordinate grids are in intervals, they're evenly spaced. And so this is drawn to scale. So we can make some reasonable assumptions on this. Now, number one, I can look at this and see that's not a rectangle, that's not a square. So we know it's probably not any of those things. Now, we haven't learned a kite yet, so I don't expect you to know that yet. Is it a trapezoid? Maybe. It looks like it could be, could not. Parallelogram, kind of iffy on that too. So just by looking at it, we can get rid of some things that we know it's not. All right, so what we're going to do is we're going to use this hint though. We're wanting to see, okay, is it a parallelogram? And we're going to use slopes. And so one of the best ways to show what a figure is with the slopes. Now that's not the only way of doing it. And there might be some other things that you need to do, but slopes is a very, very good place to start. All right, so let's go ahead and do that. Let's find the slopes of all of our sides. And so let's do the top side. So the slope of FG. Now FG is a horizontal line. And so that has a slope of 0. And so if we do the slope of GH, let's just go in order. And so GH, if we start at H, are going to go up 1, 2, 3, 4, 5, 6. So that's a rise of 6. And we're going to go right 2. And so GH has a slope of 6 over 2, which is 3. And so we found 2 of our slopes. Now the slope of the bottom side is easy. That's another horizontal line. That's got a slope of 0. And then the slope of the left side, which is FE, we count spaces. So we're going to go from E up 1, 2, 3, 4, 5, 6. So it's a rise of 6. We have a run of 1 this time. And so that's got a slope of 6. All right, so here's the bottom line to this. This is where the purpose of the slopes. Why are the slopes so important? Well, I'm going to highlight these 2 slopes that are 0. The slopes that are 0 are the tops and bottom sides. And because they have the same slope, we know that these are parallel. And so I'm just going to kind of write you a note. These are parallel to each other. And so we know that we have one pair of parallel sides. Now, the issue is that when we look at the other pair of opposite sides, the slopes are 3 and 6. Those slopes are not the same. So we do not have 2 pairs of parallel sides. We only have 1. So this is not a parallelogram. It cannot be because it doesn't have 2 pairs of parallel sides. It's only got 1. So the technical answer to this is that it's a trapezoid. Now, we haven't learned about trapezoids yet, but trapezoids have 1 pair of parallel sides and 1 only. All right, so that's where the answer to this question will come from. If this was a test question, I would just be asking you for what shape is it? And then I'd ask to see your work, your slopes, to justify that. All right, so go ahead and try the next question for me, question 8. I've graphed the question already for you a little bit. So this is what it should look like. So take a moment to graph and to find your slopes. And again, we're going to reword this. I know it says determine a parallelogram other than slopes. Let's just do slopes again. Figure out what this thing is. All right, so take a moment to calculate your slopes. We'll check your answer out here in just a second. All right, welcome back. And so let's go ahead and check your answers to this question. And so if you check all of your slopes, you should have -4/7 for 2 of the slopes and 8 for the others. And we'll just quickly kind of check your slopes here. So let's do the top side ST. So if we start at S, we're going to go down 1, 2, 3, 4. So there's the 4. And then we're going to go right 1, 2, 3, 4, 5, 6, 7. And so that's where the -4/7 came from. And if we do the same thing on the bottom side, so this is from R, we're going to go down 1, 2, 3, 4. And then write 1, 2, 3, 4, 5, 6, 7. Okay, so we have right here a pair of parallel sides. And if we check the other sides, we're going to see that they have a rise and run of 8/1. And so this is going to give us our second pair of parallel sides right here. All right, so this is a parallelogram. Now let's go over something that we're going to need in a future lesson. Because we know this is a parallelogram, the question is, can we upgrade this to a square or a rectangle or anything like that? Well, this is not a rectangle because the slopes of the sides that are touching, ST and QT are intersecting. Well, 8 and 4, -4/7 are not opposite reciprocals. And so remember, perpendicular lines have they form right angles, but they also have opposite reciprocal slopes. And so if these were truly perpendicular, like this 8 would have to be 7/4, positive 7/4, if they were opposite reciprocals. All right, so just a reminder there, we'll be looking for those when we get to rectangles and squares. We'll get to that in a future lesson, but just remember that opposite reciprocal slopes, that will help you determine if you have right angles. All right, so this is a parallelogram only. It's not upgraded to a rectangle or a rhombus or a square. All right, so just wanted to kind of quickly go over that one. Let's see if there's anything else here. All right, so this one here is a parallelogram at first glance. I also want to kind of go over this here. I think I said something incorrect there. If we actually found the side lengths, now this is a parallelogram at first glance, but if we use the 4 and the 7 that we used for the slope of ST, and we do Pythagorean theorem, 4 squared plus 7 squared, if you get your calculators and kind of crank that out there, 4 squared plus 7 squared, that is 65. And so that means this side length ST is the square root of 65 units long. Well, the side length from R to Q has the same slope and it has the same side length. And so we know that they have the same side length. So we have the square root of 65 as our side lengths. Now, here's the question. What is the side length of SR? Well, if we count spaces again, and I'm going to color this in red, we go from R up 1, 2, 3, 4, 5, 6, 7, 8, and it's got a rise of 1. If we do the Pythagorean theorem, 8 squared plus 1 squared is equal to C squared, we're going to see that this red little length right here, SR, is also the square root of 65. All right, and so all 4 sides actually have the same side length. And so this parallelogram, it is a parallelogram, but when we get to a future lesson, what we're going to learn is that all 4 sides are the same. And so this parallelogram is actually going to be upgraded to a rhombus. All right, and so we have a parallelogram there, and it is a rhombus. And so that's going to be our answer for question number 8. All right, so that's going to do it here for that lesson. We'll do rectangles on the next lesson. So that is it for today. Thank you for your time and have a good day.